Hello everyone, welcome to Vigyan Bharat. We are back again with another interesting video. Today I am going to give the complete solution of the problem which was given yesterday on this channel. And there is some good information for you before starting with this video, that if you are someone who is preparing for some good competitive examinations like IIT-JEM Mathematics or IIT-JEM Statistics 2023 examination, then you should definitely join our community, which consists of our Telegram group as well as our Facebook page. So do join those two platforms. It will definitely going to help you throughout this preparation for these examinations. You can find the details of these groups as well as the page in the about section of our channel. Also, we do have an email and an official number. If you have any queries, then feel free to drop your queries there, and you can also drop a comment in the comment box of this video, like what more content you want us to make for these examination or anything related if you are preparing in mathematics. And just last thing, that if you like this video and find it to be useful, then do like it and do share what the initiative we are doing among your friends, so that it can reach to many students like you and help them. And watch the video till the end. So without any delay, let's get started. So let's start with the solution of the video. This is that useful information which I have already told you. So you can go through this information and just watch the video to the end. This is a useful thought which you can read and motivate yourself, given by George Cantor. Just let me change the color of my pen. Yeah, George Cantor, it's perfect now. So we are going ahead with the solution of the video for the problem given yesterday. So the problem was based on integrals, and we require if someone have these two notions, the idea have what is a modulus or absolute value function, and know how to integrate an integral by parts, then this solution will be very easy to do. The solution of the problem will be easy. So let's begin. Let my capital I denotes that integral from minus infinity till infinity x e to the power alpha x minus 2 times modulus of alpha x dx. So this is my integral which I wish to evaluate. Okay, so let's just quickly discuss about something about the modulus function. Let me denote. This is how the one part of that function look like, I equal to x, and this is the another half. I will explain what it means if someone don't know what is modulus function. So the modulus function denoted by modulus of any real number x is defined piecewise as x if my x is a positive real number, 0 if x is 0, and minus of x if x is negative. This is how the modulus or the absolute function is defined. Now this is the graph of this function. It is my x where the domain of values lie. On the y-axis I have my answers, that is y equals to modulus of x. the part of the graph which lie in the first quadrant denoted by y equal to x or mod x equal to x. So this is y equal to x part and this is y equal to minus of x. Here is my origin. Fine. So there is some observations which you can make from this modulus function. Two observations, quick observations. You can easily answer by looking at its graph that this modulus of x is always non-negative for every x coming from the set of real numbers. So this is the first observation. The second observation is that range of this function modulus of x is this particular interval 0 to infinity. It can assume values in this range and the domain is pretty clear. It is the whole set of real number line. Fine. So now let's move ahead with the integral. Let me quickly note down. This was our I. Our x was varying from minus infinity till infinity. Or this is the integrand alpha x minus twice mod of alpha x dx. So what I can do, I can rewrite this integral as the sum of two integrals. One for my x varying over this part and another for my x varying over this part of the domain. You can fill the details here. This is the same. I'm not writing it again. You can note it down, the whole expression. This whole expression here as well as here. Fine. So moving ahead, I use a property here. I know in general that if a and b are any two real numbers, then modulus of their product is same as product of their individual modulus values, where a and b are real numbers. So in particular, in this my problem, I can express mod of alpha x is same as mod of alpha times mod of x. Fine. Now I come over here, like let me call this, suppose a star. Then my star becomes, for my x running from minus infinity to 0, x e to the power alpha x minus 2 times this quantity now can be written in terms of this product, likewise the another integral. Fine. Now to move ahead, I use this definition over there, the values, how I can express my modulus of x in terms of different parts of the domain. So here, because my x varies over minus infinity to 0, that is x is negative over this part, so this modulus of x can be written as minus of x. And now you understand what I'm trying to say here this way. Likewise, the second integral, in that my modulus of x becomes simply x. Fine. Okay. Now here, just a simple some calculations you can easily, I'm writing it directly. It becomes x e to the power alpha x plus twice mod alpha x dx, and the second part becomes 0 to infinity x e to the power alpha x, this will remain the same. Fine. Okay, so till here, let me call this my u1, my first equation. Okay, yeah. Now this Let me change the color. Now the problem boils down to choose value of modulus alpha. Now what is going to happen now? In order to solve it further, we have to see what this quantity modulus of alpha can assume its values. So it is again quite easy if you again use this definition, this one over here, replacing x by alpha everywhere. So you find the answer. But remember, if you observe here, yesterday in the problem I mentioned that my alpha is in R and this alpha is non-zero. This I mentioned, if you remember. So using the definition, I left with only I have to consider only the two possible cases. So we consider the following two cases. That is, my case 1, when my mod alpha assumes a value of alpha, that is, my alpha is positive. I'm assuming my alpha is positive. So in this particular case, if you see, in this particular case, equation 1, this equation 1 will reduce to, if I choose my mod alpha to be alpha, then equation 1 becomes, this I becomes, I'm writing directly, minus infinity to 0. You can verify that, x e to the power 3 alpha x dx plus from 0 to infinity x e to the power minus alpha x dx. Now we have solved the problem, reduced the problem to a very, in terms of integration of two simple integrals, although I encourage you to solve themselves. But now to proceed further from here, there can be many ways to solve the problem. If someone has a knowledge of I would say that gamma function, if someone knows, then maybe you can reduce it in terms of that function and directly evaluate its value. But because I have told you that I will be using the concept of byparts, which I told in the very starting. So let's proceed further with that. Now I can rewrite my I as in terms of byparts. So this is my part 1, this is my part 2, this is my part 1, this is my part 2, because the bypart method, integration by bypart method, follows this rule I, L, A, P, E. This is the order of the functions in which we have to take the parts. That is, E stands for this exponential, I stands for inverse, L stands for logarithm, A stands for algebraic, and T stands for trigonometric. So because my exponential function will always be going to, if it is present in the integrand, it will be always going to be at the last, that is, it will always going to play the role of the second part. So I'm not bothered which is at the first. So I just assume that this is second, so the other one have to be the first one. Okay, so now my I will become, now most of the students will do this mistake. They will take the limit directly in this integrand, in this integral, and integrate and substitute it. But this is not the case. You cannot, in general, it's not possible to directly write the value when you are integrating as minus infinity. So this mistake most of the students do. So try to avoid that mistake. While for the sake of calculation, you can do that. But in general, when you are writing some examination, so try to avoid that mistake. Take first the limit and then integrate that finite integral and then take its limit till where your variable tend towards infinity. Fine. This was 1, this was like 2, this was 1, this was 2. Okay. Now here I am again using that by part. So now you can, let me just quickly note down the solution for you. First function as it is, integral of second e to the power 3 alpha x dx minus integral d by dx, this one, then again integral y to 0 e to the power 3 alpha x dx and this whole of dx. So this is the first part. This is the first part. Likewise for the first integral, likewise for the second. You have to take the limit when your y tends toward infinity. Just let me quickly note down the steps, and I encourage you to solve these intermediate steps yourself without looking at the solution. You can just keep it for a reference in case you struck somewhere and come here and look at it. I have also solved myself, so in case if there is some mistake which I attempt somewhere, then do correct me. Fine. Send this whole of dx and this limit this way. Now I'm skipping some intermediate calculation and I'm moving directly. If you will solve this, at the last you will going to get an expression something like this. While you substitute the limit and use the fact that the exponential function, I just note something good for you, limit of, in general I'm writing now, limit of e to the power y when y tends to minus infinity is 0, and limit of e to the power y when y tends toward infinity is infinity. And this limit what I'm writing is not a real number, it does not exist, this is infinity is not a real number. Okay, and just one more thing, that you will require to use L'Hopital's somewhere between this when you will be calculating, so this will come into the picture. So try to verify this at what stage you encounter where you have to make use of this L'Hopital's rule. Okay, minus 1 by alpha square 0 minus 1. So while you will simplify this, at the last you will be left with this one, this quantity. I'll write it directly for you. 8 by 9 times 1 by alpha square. Because my alpha was positive, I can rewrite it as 1 by alpha times 1 by modulus of alpha, and this will be 8 by 9, yeah, 1 by alpha mod alpha. Now in the second case, I left it to you when you will solve it further. In case 2, when your alpha will be negative, when alpha is negative, what you can do, you can replace your alpha by some minus of beta where this beta is positive. So you can do that. In that particular case, you can solve the whole expression, and after when you replace the value of beta by minus alpha, this implies beta is minus alpha. When you will at the end when you will replace the value of I in the second case, you will going to get will be this one. So yeah, on combining the answers from both the cases, what you will find that the correct option would be, but I can be written as 8 by 9 1 by alpha mod alpha, that is 8 by 9 alpha mod alpha whole inverse. So this will be the correct answer. Therefore, option D is correct. Option D is correct. Now, this was the way how someone, if you are writing some examination, some university examination, and this kind of problem come, then this is the way to solve it. But when you are attempting some entrance exam like IIT JAM or something, some different exams like I say KOLKATA, CMI exam, so there you don't have that much time. So for that, for solving that particular problems, now I tell you what is the good method to save your time. What you can do, because you use this information here, alpha is a real number and it is 0. So assume two cases. Case 1, when alpha is positive, so pick a particular value. What you have to do, you have to choose a particular value of alpha, replace it everywhere in this particular integrand, and then directly when you have to solve till equation 1, after replace the value of alpha, either a positive value, suppose say 1, a negative value, suppose say -1, and you can directly eliminate the steps, you can directly eliminate the options given to you. So this way you can save your time and mark the correct option. I hope you find this problem to be very interesting, and just at the end I would say that if you like this video, then do like it and do share about our initiative among your friends, and do subscribe to the channel. Press the bell icon for receiving notification at the earliest, and we'll meet again in a good problem very soon.